Hi there, welcome back. My name is Steve and I'm working on a racing game and I'm developing it in Unity. This is my devlog series and I think this is video number 20. So that being said, I've had a few questions about the AI system, so I wanted to jump back into my demo project. Basically, this is the package that I sell on the asset store and I'm not trying to advertise this package. I'm really just trying to show what I built and what I'm using. So I was having some questions about the AI system, and recently I've been looking into all of the new dots technology, and specifically I'm looking at the C# job system, and I want to basically jobify my AI system. So since I don't have the project that I'm actually working on my game set up with traffic yet, I'm going to jump into this scene and I could show you some of what it looks like. So this is a fully configured traffic demo. There are about 100 cars in the scene driving around, and this is the traffic system that I wrote. So right now my goal is to basically redevelop this traffic system and use the C# job system to do that. So I had a few questions about the way my traffic system works, and so I'm just going to jump into it. And so basically what I do is I have AI vehicles. So for example, let me go ahead and find one of these vehicles, and then I'll do a breakdown of what the system logic actually looks like. So the AI vehicles they're actually pretty optimized, the traffic vehicles. All they have is a rigid body, the car drive system, and the car AI system. So the car AI system is basically all of the logic that's gathered, and what it does is it passes inputs into the drive system. So that being said, if we take a look at some of the objects that are on the AI car, it also has a bunch of sensors. And for this, let me actually go ahead and enable all of the debug settings. So I have car AI settings for traffic. Let me go ahead and check that out. I use Perforce. So in here, there's a bunch of settings, and I'm pretty sure I have a debug setting that show editor gizmos. There we go. That's not the right one. I don't know what controls the sensors. There's a control for it somewhere. Anyway, I'll just manually grab all of these sensors and enable the debug gizmo. So this vehicle, all of the vehicles have, let's see, they have 9, is that right? Yeah, so they have 9 forward-facing sensors and 2 side-facing sensors. So let me toggle some of these off and you could see them a little bit better. So basically I use a box cast for this, and I call them volume sensors. And yeah, I just wrote this logic where all of these sensors are basically hooked up and they have all of these values that they can detect. And I don't remember where that information is stored off the top of my head. So I know in the detection data array, that's where I hold my sensors. Yeah, so this is actually where all of the data comes in. So what I've done here is I've just named all of the sensors, and really I'm detecting what layer they hit, what tag they hit, if they hit something, and the distance to what was hit. And with that information, that's basically what the AI uses to detect if there's a vehicle to the left or the right, if it's trying to change lanes, and if there's something in its way, it won't be able to change lanes if there's something to the left or the right. So I use these sensors to basically determine what's around the vehicle. The left and the right sensors go a little bit farther back from the vehicle. That way, basically, if a car is going to change into the left lane, for example, like this car here, if there's a car behind him, I don't want the AI car to be able to change lanes if the car is too close and it's in the lane next to him. And that's basically the idea for the sensors. So I have a total of 11 sensors on each vehicle. And yeah, it can become an expensive process once you start scaling up your vehicles. And that's one of the things I want to put in the C# job system. It was actually the first thing that I tried to put in, but yeah, I didn't have good results with it. I still need to figure out how to do raycasts through parallel jobs. But that being said, there's also a ton of other logic that is used. So the car AI system, for example, if I pop that open, it has a few different. So in fixed update, it's basically running through this logic. First, it gets the basic route progress, then it checks if it's lost, and then it uses route logic, and then I have a check auto caution distance threshold, and then a move method. And I'll actually jump back into the car AI script in a minute when I go back to my racing game project, but so in general, the AI cars have 11 sensors, and that's in the detection data. And then the car AI script that I just showed you with all of that logic, those methods that are called in fixed update, they're basically they're acting on all of that sensor data. And the AI cars also have where are they in here? So this scene is consisting of, I'm looking for the waypoint routes. So just to give you an idea how many, these are the car AI waypoint routes. So we can see there's little colliders all around, and each route is basically on a road. So for every lane of every road, there's a route on it. And then there's also routes in the intersections that connect one route to another. So when the AI cars get to an intersection, they basically, the intersection, the endpoint of the route that they were on connects to an intersection route. And that intersection route will connect to another road route. And basically that's how the AI system works. I have the cars that are driving on waypoint routes, and then they use the sensors to detect if there's something in front of it, and if there is, then they'll slow down and stop for it. And then on top of that, to get the traffic lights to work, I have traffic light managers. So here's a traffic light manager. It's kind of uneventful. Traffic light manager basically consists of just an array of, let me get this off of debug mode. Basically it just consists of an array of traffic lights, and in those traffic lights, that I just sequence them. So I have an on duration, and there's only one set of traffic lights enabled at any given time. So for the first sequence, these 4 traffic lights are enabled, and then when the second sequence is on, that only that one traffic light is enabled. So basically what that is I have this single lane road hooked up as traffic light 4, and when that traffic light is enabled, no other traffic lights are on. So these other 4 turn to red. And then when these 4 are on, there's traffic flowing on each in each direction, and the single lane is stopped. And I could just create an additional indexes if I have more complex intersections. But the traffic light management is basically just a timer that's setting these traffic lights either to their proper state. And then what these traffic lights do is they have a reference to waypoint routes. So this particular traffic light that I have selected, which is this one right here in the right lane, it is controlling this AI waypoint route. And basically whenever the traffic light turns red, it will send the message to the first vehicle to stop driving, whichever vehicle is at this route. So basically when a vehicle gets to the final waypoint in the waypoint route logic, it's going to check to see if it can continue on to the next route. And that variable is controlled by the traffic light. So if the traffic light is green, the AI vehicle, the Boolean value is set to true. Yes, the AI can continue. And if it's red, no, the AI can't continue. So it'll stop that vehicle. And then all of the vehicles behind it use their sensors to detect that vehicle, and they'll just slow down and stop. Pretty simple system. I mean, there's a ton of logic that's built into it. And when I say that I spent a bunch of time, like over the last few years, writing all of the systems and the logic and testing for the game that I'm building, this was a big part of that logic, creating this AI system, figuring out how I want the system to work, actually getting it to work, and just constantly iterating and testing. That was the hard part. So that being said, yeah, I'll just go ahead and unpause it and let you see it for a few minutes or a few seconds. But this is the AI traffic system, and the way it's set up in this project, that's kind of the limit. So if you've been following along so far, you've seen that the world that I want to build for my game is a lot bigger than this scene. So that being said, I have to optimize the traffic system to be able to fill that world up with cars. And that's just something I'm interested in. I like building systems, and I think if there's one thing that I enjoy the most, it's just programming complex logic and the joy that you get when you build something that's insanely complex and it works. That was the coolest feeling when I finished this. I remember working up to building this system, and it was hard, and a lot of times I just kind of wanted to give up, and I was like, there's other traffic systems on the store. If I want to make my game, I could just use those. But the thing is, when you use other people's systems, this is coming from a programmer, I've always found limitations in their systems, and I always go in and rewrite a bunch of stuff. So that being said, some of the systems on the store were not open source, and they had DLLs and all this other stuff, and they were still kind of expensive. So that being said, I just didn't want to deal with any of that. I actually tried using, what was it called? I forget the name of it. There's another developer that makes racing kits, and he also made an AI system, and I tried using his system, and I just ran into so many limitations using the DLL package, and I was like, this is a waste. And it just kind of got me to the point where I ended up writing my own system. But now that it's done and I use it in my own project, just go ahead and open that. I'm really happy I took the time to write it, even though it took a long time. I feel like by the time I actually finish my game and get it to a good point, it'll be a really good feeling to know that I wrote most all of that code myself, even though it took a very long time. So I'm back in my project now, and I'm going to jump into the code a little bit more, what I'm doing. So what I have here is, at this point, I've really started hacking into the code and basically preparing to rewrite it, and I've done a lot. And actually, the little bit of a change that I've showed you so far has actually gained me like 2 frames a second, which is pretty cool, because I haven't actually made any optimizations yet. So what I did was I wrote a car AI sensor job controller, and I'll open that one. And what that does is all of the AI sensors basically register to this controller. So we can see that there's probably like 20 cars in the scene right now. We have 307 sensors, and this job controller is basically responsible. There is no job system in it yet. When I tried to write the job system for that, it just wasn't. I don't think that's the right project. When I tried to write the job system, I was just having some issues, so I needed to do some more research. But basically, this is all commented out because it wasn't working. But this is the sensor logic. So instead of having all of those sensors update themselves, I have a single controller that has a for loop, and it just goes through and updates all of the sensors in its own update. And that saves me from having, obviously, all of those different mono behaviors running fixed update. Now I only have one, and it's running a for loop. So the next step would be to take this and toss it into a job, which I just need to figure out how to do the physics. And I know there's some limitations with physics. I had something set up and I thought it was going to work, but then I realized that you couldn't do the box cast off of the main thread. And then I started redoing a bunch of stuff, and yeah, anyway, I need to figure out some more stuff with the sensor job controller. The other one that I wrote, and this will kind of give you a little bit more insight as to how much code is actually being used for the car AI system. This is it. This is what I did was I took all of those methods and I brought them into this car AI job controller. And right now there's no jobs, but basically I have all my for loops and I have all my logic for all of the cars. The same thing I did with the sensors in this one car AI job controller. And that's all of the logic is actually operating from this controller for all of those cars in the scene right now. And to me, that was it's what you have to do. So like I'm looking at a giant wall of code initially, like these were all much smaller methods and just a little bit easier to digest. But now I have this giant wall of text inside a for loop. So what I need to do is break it down and figure out how to turn it into jobs. But at the same time, this is the logic that was being executed for the AI system. And that's what I've been working on for the last 2 days. I looked into the ECS system and I looked into the job system, found this channel on YouTube. He's a professional indie developer. His channel is called Code Monkey, and he just did a really good job at explaining how the systems work, and he had a really thorough tutorial with some good examples. And that being said, I'm sure that all of the logic that is in this giant wall of text, I'm sure I can jobify probably all of it, and that's my goal. And once I do that, I can probably have a lot more AI vehicles, which would be cool. So basically that's where I'm at. I'm working on a lot of code, so there's no actual visual progress, but once I'm done, if it works out the way that I'd like it to, I'll probably be able to have 1,000 cars really easily, whereas having 100 cars was kind of the limit before. So anyway, thanks for checking it out. That's my AI system for you, and that's I basically described the logic for it, how the system works, and what I'm trying to do to optimize it a little bit more. Let me know what you think. I'll see you in the next video. Bye.